Hello, my Flat Earth family. This is Marilyn's Spirit Level. This question has been on my mind for a number of months. All sunrises on equinox are due east. And the question is, how can that be? And I got a revelation about that this morning, and I am going to let you know what it is because I think it's very important that we share our information as soon as we get it, even though it's not totally worked out. Because if somebody hears this in the community and they say, well, that would certainly make a difference in the problem that I'm working on. So if we do that and share our information right away, it might give light to somebody else. So, all sunrises on the equinox are due east. And I mean, how can that be? How can it be? Well, let's look at the maps. Here we have the Gleason's map. And now when you have the Gleason's map, you know that, I don't have my pointer now. I don't know what I did with my pointer. Well, you have the Gleason's map, and there's no way that we can make, from looking at the longitudes, when you're standing here and your compass is pointing to the North Pole, you're standing on this longitude, and there are numerous ones in between, so it doesn't have to be on one of these physically drawn lines. But due east, when your compass is pointing north, would be directly away from that. So it would be pointing in this direction, or this, or is. Anything that's perpendicular to that line is what due east would be. So how can this be? How can we figure this out? All right. So there's a couple of things that when we have the globe model, it seems to work because their sun is very distant. Over here, their sun, and it shines the whole side of this globe. So it seems to really work that it's coming here on the equator. And so, yeah, everything would be due east, right? On the equinox, because it's so far away anyway. How can they tell? Right? Well, I think this is going to be enlightening for everybody, even some of the globalists. There's a couple things I know is that I've been teaching this torus field. Now the torus field, you know, it has a North Pole here in the center, and this is one continuous strand, so it goes in a spiral. And we live on the inertial plane, like this, inside the torus field. So we have the electricity coming up out of the North Pole, and it's diamagnetism holding us onto the inertial plane. The South Pole is down here. And that just was not long ago coming to that. It was like about a month and a half ago coming to realize that. But, you know, when you say things, it wasn't a realization, because I knew that when this was a magnet in here, the inertial plane and the torus field and all that, I knew the South Pole had to be down here. But when you get it, you see something in theory or in application with a magnet, it takes some time for you to process it and put it in terms of, okay, now I feel confident enough teaching this. And so, yeah. So there it is. So the South Pole is not Antarctica. Antarctica, and you know they don't ever even claim Antarctica is the South Pole. They put up a fake barber pole and dance around it like ninnies. So, so here we have Antarctica that goes around, but that is not south. So we're gathering all this information, but this seems to be north. So what other things have come into view that are going to help us with some clues on this? Well, let's look at this. We have the yin and the yang here. Now, we all know that symbol, right? I don't know if I can make that smaller, but we have the yin and the yang symbol. And what's interesting to note is this line is curved. Do you see how that's curved? If I could trace it, I'm doing it with my left hand. And then this one is also curved. So what happens when you are standing on that curved line? Your due east is not this way, is it? Your due east is this way. So what am I saying? Am I saying the yin and the yang is the electrical torus field? Well, no, because we know this is the light. This is the light. And that's the darkness. So what is it then? Well, I think the path, I think this shows part of the torus field. So if the North Pole is here in the center, then this could very well be the torus field. Here's the center. That could be the shape of the torus field that we are in, as well as this side here. So, well then, gee, Marilyn, what are you saying now? Okay. When you are on, let's say, here's that South Africa. And if you're standing on here, then perpendicular to that would be up here. So, what are we doing then? What is that? Well, I guess what I'm saying is that our compass does not point north. I'm saying our compass does not point north. Let's look at this again here. What I'm saying is, let me say it again. I'm saying our compass does not point north. I'm saying our compass is showing you the direction and the flow of the torus field. That's what I'm saying here. Now, how does that happen? Okay, let's look. All right, so when you have a compass, let me set this down here again. Sorry, I'm just doing this really quick here. When you have a compass, we are always told, and this is something else, see? We have to be told that this points north. So, does it point to the North Pole? That's the question. Does that arrow point to the North Pole? Or does it just align itself with the electricity flow that eventually goes to the North Pole or comes out of the North Pole? So when you look at the yin and the yang here, oh, sorry, get rid of that. Which is the light pattern. And look how it kind of swoops down here. And I think the light actually, there's fiber optics in the dome, which allows this to go along that swoop, along that torus field. And there's got to be something with that. But, okay, so when you have your compass, the only way we know believe it points to the North Pole is because that arrow was painted on there. And they tell us it points to the North Pole. Well, maybe it doesn't. Maybe it just shows us the direction of flow. Maybe it's just showing us the polarity of the flow of the torus field. Now, how do you get if it's coming to or going away from the north? You just paint the arrow on this side, or you paint the arrow on that side. So how do we determine the flow? Well, I kind of look at the aurora borealis, and it does not seem to be going into, it seems to be coming out of the North Pole. So, and I just think that that's the way it is, but it could be the opposite. We have to consider that. So here's a lot of questions for you guys who are onto these things. I'm just putting this out there real quick, but I want you to really start thinking about this, that the torus field is really the direction of flow, not the direction so much as the flow pattern. The compass is really aligning itself with the pattern of the torus field, and it's not really pointing to the pole itself. So if that's true, then when you're anywhere on that line, you've got a due east. You've got due east when the on the equinoxes. So see how one thing can open up a number of questions, and we can look at this and see what are we really looking at. That's the thing I keep telling people. You really don't know what you're looking at when they're talking about curvature, and we have the mirroring effect, you know, and the globalists ignore it. We have to say, well, gee, guys, you don't know what you're looking at. You don't know. And so go to my AC space NJ, Atlantic City, New Jersey, 8 of 8. And that will give you all the information you need on looking for the horizon line and the mirroring line. But I thought this was really interesting because the compass does not point to the North Pole. It just points to the field, the energy field. It is aligning itself with the energy field. And I want you to notice something, that this torus field is like, it's going this way. So we have the right-hand rule. So, I don't know. Could that be wrong? I don't know. Are we going to, you know, find out that they're lying to us about something else too? Or, you know, has the right-hand rule been proven? Is there a reason that when we do a small scale experiment that it's different? Or can we just apply it to the Earth that we live in here with the same parameters that we are in the laboratory? I don't know. That would really be good. I'm going to give this to somebody and ask them to look at it. But that would certainly solve this one problem that I've been thinking about. And I wish I had a flat earther who was really up on this stuff. But that's the question I was trying to answer. So thanks for listening, and I hope to get some really awesome comments in the comment section. And maybe I'll put this up as a premiere tonight and see if anybody's interested in this. Thanks. Have a great day. Bye.